Hello everyone. So the problem which we will solve now is minimum operations to achieve at least k peaks. So the problem is hard marked and it is a good problem, right? Let's read the problem first. You're given a circular integer array nums of length n and integer I is a peak if its value is strictly greater than its neighbors, right? That is the previous neighbor of I is nums of I minus 1 if I is greater than 0, else nums of n minus 1, and the next neighbor will be nums of I plus 1 if I is less than n minus 1, otherwise it will be nums of 0, right? So I hope this is clear to you. Like, let's say I had, let's take it, if I had elements, let's change the color of it. All right. So let's say I had elements 1, 2, 0, 1, 2, 3, and 4. So if you are at the last element, the next element will be 0, right? And if you are at 0, your previous element will be 4, right? And for any other element, for let's say like 2, your next element will be 3. And if you are at 2, your previous element will be 1. All right. So I hope this much is clear to you, right? All right. So you are allowed to perform the operations following any number of times. You can choose any index I and increase nums of I by 1, right? Return an integer denoting the minimum number of operations required to make the array contain at least k peaks, right? If it's impossible, then we need to return a minus 1. All right. So I hope the problem statement is clear to you. Let's look at an example. A better example would be uh, 4, 5, 3, 6 and k equal to 2, right? 4, 5, 3, 6, right? Um, Let me erase this quickly. 4, 5, 3, 6, right? So 4, 5, 3, 6 and k is equal to 2, right? So if you look at it, it already has a peak. 5 is a peak and 6 is already a peak. Why 5 is a peak? Because 5 is greater than both of its previous element and 6 previous element is 3 and next element is 4. So I think the test case is not that effective, right? Let's look at another test case. Let's look at 2 and 2 and k equal to 1, right? So if the array is 2, 1, 2 and if k is equal to 1, right? So you need to make at any one element as peak, right? Let's say you try this element, right? If you try to make this element as a peak, right? So its previous element is 2, right? Its next element is 1. So in that case, for the first element, you will require at least plus 1. So the array becomes 3, 1, 2, right? And now it is a peak, right? So the first one will get a plus 1, right? Similarly, if you are at 1, right? Now its previous will be 2 and its next will is also 2. So you need to increase what is the maximum amount of both 2, right? So you need to make it at least 3 so that you can be greater than, you can be a peak, right? So for the second element to be a peak, we need to add a plus 2, right? And so it becomes 2, 3 and 2 and now this is a peak, right? Similarly, for third element to be a peak, previous is 1 and next is 2, so the greatest is 2, so you need to add at least 1, right? Because see, I hope this is clear to you, because 2 has a previous, this 2 has a previous of 1 and next of 2, right? So out of these two, 2 is maximum, right? So you need to add a plus 1 to make it 2, 1, 3, and now your previous and next both are on the same page, right? All right. So I hope till this point we are done with the problem, understanding the problem statement, right? So let's now look at the solution, right? I hope the problem statement and few test cases were clear, right? Now let's look at how can we approach the problem, right? Now tell me one thing. If I said if your k was greater than n by 2, right? Your n is, let's say, you had 6 elements, right? 1, 2, 3, 4, 5, 6. So this can be a peak, right? If you make this element as a peak, right? Let me mark this as blue. If you mark this, if this is your peak, then this can't be your peak, but this can be your peak, right? Then again this can't be your peak, this can be your peak, right? And this cannot be your peak, right? So at max we can say, at max we can have n by 2 elements as peak, right? Even if you had a 7, let's say, right, you had a 7, right? So as you have already marked 1 as your peak, right? Now 7 can't be your peak because you had, means for 7 next element will be 1, right? Because it is a circular array, right? So I hope till this point we are clear that if your k is greater than n by 2, then you need to return a -1, right? This case is clear. This is our first edge case, right? First edge case. Now why this is important, I will tell you later in the video, right? But up till now I hope this point is clear that if k is greater than n by 2, then you need to return a -1, because creating and more than n by 2 elements as the peaks is not possible. All right. So till this point, I hope things were clear, right? Now think of this as one more test case, right? Let's say now you just now you had a let's say you had a thought, right? Let's say you had 5 elements, right? Name it 1, 2, 3, 4, 5, right? So if you make 1 as your peak, let's say for a moment, let's say you make 1 your peak, then you can make 3 as your peak, but you can't make 5 as your peak, right? So what is your observation? That if you make first element as peak, then last element can't be your peak. Last element can't be your peak, right? Let's say you didn't make 1 as your peak, right? 1, 2, 3, 4, 5, right? Just be a bit patient with hard problems, then you will understand that it is not that tough, right? You need to just break the pieces one by one in order to reach to the point where the problem can be solved, right? So let's say you didn't pick 1 as your peak, so you can make 2 as your peak, you can make 4 as your peak, right? Or rather you can make 3 as your peak and 5 as your peak. So if you don't take your first element as your peak, then you have a probability, means you have a strong probability, then you can make that, you can make the last element strong probability that you can make your last element a peak. All right, right? So till this point I hope things are clear to you, right? That if you take the first element, last element can't be your peak, and if you take the last element, your first element can never be a peak, right? So till this point I hope we are on the same line. All right, so let's now look at the, so this is the first observation, right? I think writing this observation will help us a lot, right? So let me jot down this point, that first and last can never be peak together. I hope this point is very obvious, but using this point we can exploit this point in future to, like, you will understand why I'm saying, why I'm focusing on this point, right? You can we first and last can never be peak together, right? And this is obvious, right? Okay, so now let's move to the problem, right? So if you think of the problem, you need to make k elements as your peaks, right? Now you have the opportunity, right? You have really sorry for this, you have the opportunity t to make which element should be a peak, which element will be a peak, right? Now this gets interesting to you, right? Why I'm saying this, right? Let's say uh, you had many elements, right? Let's say you had 2, 3, 5, 1, 7, 1, then let's say 0, then 5, right? So now you have the options, like, do you want to make this one a peak, right? If you make this one a peak, there is a restriction, as we have seen, right? Because if we make this element a peak, wait a second, if we make this element a peak, then this element can't be a peak, right? Neither can this be a peak, right? So we will simply move index plus 2, whatever the index is, right? Right? All right, so you have the opportunity to make which element do you want to make peak, because see, we need to minimize the operations, right? We need to minimize the cost as well, right? Think of the problem as these, right? So you have multiple opportunities, right? You have multiple opportunities, that is the first point that you get, right? And if you have multiple opportunities, the second is you need to minimize the cost, right? Now, whenever you have multiple opportunities and you need to minimize something, what does come to your mind? I think that thing which comes to your mind when you think of multiple opportunities and minimizing or maximizing things in a single line, then the thing that should come to your mind is recursion or dynamic programming, right? Any one should click your mind as soon as possible, right? All right, so now the problem becomes interesting, right? Now let's look why the problem is interesting. I will show how recursive solutions can be written of this, right? So let's say my solve function will have index, right? And left means how many more elements we need to make peak, right? So these two are the points, right? Now my first claim is, let's make the base case, right? So how will you make the base case? Base case is simple. If my left is equal to 0, means I don't have any element left, return 0, right? This is the first and the most important base case, right? All right, okay, I do have one more base case, so I will leave the place for that. Let's move further. Let's say I had any element. Now we need to make some curriculum activities, right? Let's say I'm at index 0, 1, 2, 3, 4, right? So if you are at 0, right, and you want to find your previous, then how will you find your previous? There's a formula to it, which we can say, I will like make you understand as well. So if you are at index end, right, then going to -1 plus n modulo n, right? Now how this works, look at this. If you are at index 0, right, you do a -1 plus size of the array is 5 modulo 5, right? So it becomes 5 minus 1, which is 4 modulo 5, which is 4. And if you look closely to the problem, 4 is the previous element, right? So this is the way we can find previous. Let's look quickly how for 1. For 1, it will be 1 minus 1 plus 5 modulo 5, right? Which is 5 modulo 5, which is 0, right? So 1 has a previous which is 0, and that's true, right? So if you don't know this formula helps you like save lines for problems where you write if else, if index is 0, then you can do that. But this thing will help you in circular arrays a lot, right? So previous have been understood. Let's quickly look at if we had 1 2 3 4 5, and let's say we had 3. How will we find next, right? So next can be find as index plus 1. See, there is nothing new to it, right? You are going to index plus 1 and you are doing plus n modulo n, so that you are in the same bracket, right? So for 3, 3 plus 1, which is 4, plus n, which is 5, modulo n, which is 9 modulo 5, right? Let's make it 4 size so that we can be, yeah. So it becomes 4 plus 5, 9 modulo 5. 9 modulo 5 is 4, right? And see, for index 3, your next element is 4, right? So that gives us a correct answer. So I hope this point was clear to you, right? So till now we have understood how will we find previous, how will we find next. Now let's try to understand what is our recursive solution, right? So till now this thing is clear to you. Now if I'm trying to say that let's find the cost, how will you find the cost? I'm saying, let's say for any element, if I had 0, 1, 2, 3, right, I do have the next, I do have the previous. Let's find, let's say for 2, right, you need to find, you have this data with you that okay, this element is my previous, this element is my next. Now let's say this was 3 and this was, let's say 5 7, right, and let's say that this was 1, right? So in order to make this element a peak, how much cost will it take? Let's try to understand it, right? So you need to understand that for this element to be peak, this should be greater than this and this as well, right? So to make it greater than both of the elements, you need to understand which element is a maximum out of both of these, right? So maximum is 7, right? So we did a max of nums of I comma nums of max of previous comma next. We know how to find previous and next, right? So we have the maximum, we have 7, and by adding a plus 1 to that, we will have a maximum with us, right? So maximum will be 8, right? Now your maxi is 8. You have your maxi stored as 8. Now what will be the cost to make that element a peak? You tell me. You had a 3, You want to make it 8. How much cost will it take? It will take 5. How did you find it? So you found it using 8 minus 3, right? But there might be cases now where this element was already a peak. Let's say it was already 10, right? So when you find the cost, you will say 8 minus 10. It will give you minus 2. That, what does that mean? That means you don't need to spend any extra money on that. It's already a peak, right? So you will do max of 0 comma this element. Now why max of 0? I hope it is clear, because you don't want any negative elements with you, right? See, I am bringing you with whole process of how do we think us of a solution, right? So I hope till this point we are clear, right? Now let's try to understand that uh, what are the next steps, right? So we do know the cost, right? Now let's say you want to pick this element, right? What do we mean by we want to pick this element? That means that if you had, let's say, this element, you want to make it as a peak, right? And so to make this pick, we need to pick this element, right? So let's say to make pick, I'm saying pick. So if you make this element and you're picking this, you need to spend cost rupees, whatever the cost is, right? Plus solve function will be called. And if you make this element as peak, you will directly jump into I plus 2, right? Because you can't make this element as peak anymore, right? This becomes a cross, right? This also becomes a cross, but since we are moving on the right direction, we don't care about this anymore, right? So if you have make this element a peak, right, you will have to jump this element, right? You will go to index plus 2, right? So your solve function becomes solve of index plus 2, right? And if you have decided to make this as peak, your left will be left minus 1. All right, let's say you think, no, I won't be picking up this up, right? So you will add a 0 to your cost and solve function will go to index plus 1, right? Let's say you thought, no, I don't want to make this element a peak, right? So make this element a peak, try to make this element a peak, right? Left remains left in that case, right? And you need to find minimum of pick comma not pick, right? Don't run away, the solution is still not yet completed, right? We need to take care of few more things, right? So I hope base one thing is left is base case, one more base case is left, but one base case more can be left, right? Now let's try to understand. I hope the recursion part is clear to you. Yes, I can make it small. So really sorry. So this is the recursion part. All right, so let's try to uh, move the page a bit down. I'm actually new with these, right? uh, okay, so base recursion is done, right? Now let's think of what more can we do in this, right? uh, yes, really sorry for that. So now my next step is, let's say you thought of solving the problem, you came to this point. Now if you submit this, will it get accepted? No. Why it won't get accepted? Because you didn't handle a small edge case. Now what was that edge case? Let's look at that, right? Let's say what I was talking about, right? If you make this element a peak, then you can't make this element a peak, right? So you can't make this a peak, right? So you need to have the information that whether we started with 1 or not, right? This information should be with you, right? So we what we can do is simply add, like we can call this function twice. So solve function, we will be starting from 0. Okay, okay, we have the 0, we let's call it int answer 1, right? So answer 1 stores, we will be starting from 0, we will have left elements left. And one more thing what we can do is add end over this point. See, end is not a changing variable, right? So in dynamic programming, whatever the changing constraints are there in your time, in your function, that things only matters, that things make the time complexity, right? So left is there, and you said, okay, if I'm using 0, right, then let's say whatever my n minus 1 element is can't be picked. So I need to end before n minus 1, that is on end should be n minus 2, right? And let's say I started with 1, right? That can also be a case, right? And answer 2 is simply start from 0, simply start from 1, right? All right, 1. Your left is still left, right? That is k, right? K is your left, right? And now you can end on n minus 1, right? So these two will give you your answers, and you need to return minimum of these, right? I hope the recursion part is clear to you. Now let's move to the base case which I was talking about, right? One base case was left, right? The base case is if your index has already exceeded your end, right? If your index has exceeded end and you have not like reported that left is not still not 0, right? Then you need to return 1e9, that is the maximum value, so that your that case doesn't count in your answer. All right, so we have understood recursion, what code we need to write for recursion, pick comma not pick, right? Now now we have understood why we are using int answer 1 and int answer 2. Now let's look at the code. I hope the explanation was on point for you. If like if I was not able to explain anything, feel free to say in comments. I will be like more than grateful to help you out or improve at any point that is like improvable, right? Now let's look at the code. The code is, I have written the code as uh, easily as it could be, right? So first what I did is, first the thought of that if k is greater than n by 2, right? So simply you can't have that element, right? Because I hope this is not a tough thought for you, that it won't be possible to make more than k by 2 elements. Let's say you had 6 elements, then at max you can have 3 elements as your peak. You can't have 4 elements as your peak, right? Okay, so I'm like explaining why I have written this as well, right? So I have created a dp, right? Dp is created, and in answer 1 starts from 0 and it ends on n minus 2, right? Similarly again I have created dp answer 2 and it starts from 1 and end at n minus 1, right? And we need to return minimum of answer 1 comma answer 2. Now let's look at the main solve function, right? So if your left is 0, return 0, right? Obviously if your left has already, it means you have created all the peaks, then return a 0. If your index is already greater than end, then you need to return 1e9. That boss, this is not a possible path, you need to break down right here, right? And this is, I hope we know that this is memoization part, so I will like quickly jump into that as well. First look at the previous. How did we find previous? The same formula I used. The next, the same formula I used, right? And the maxi is max of nums of previous comma nums of next plus 1, right? Just to make it the element a bigger by 1, right? And the cost will be max of 0 comma maxi minus nums of index. I hope these points, I don't need to repeat these points again, right? Int pick is cost, whatever the cost came at this point, plus solve function. And if you pick this up, your left will be left minus 1 and you will be moved to index plus 2. I hope this is also clear, that if you have picked this element, then this can't be your peak again, right? Okay, and if you don't pick that element, then you have num, you will have left and index plus 1, you move to the next index, and you have end as well, right? So return dp of ind left, and that will be minimum of pick comma not pick. I hope this part is like, if recursion is clear to you, then this part won't be a big problem for you, right? Because we know that if we have a recursive code for our solution, right, we just need, like if you have solve function, right, and the solve function has index and k, or which is the left, as a changing parameters, then your dp will only have these as your changing parameters, right? Whatever the change, I hope we know that, right? That if in your dp, whatever the changing parameters are, you just need to make them as your dp parameters, right? If you want an explanation of what does this line mean, so my dp of index comma left stores that till index I, right? Till index, let's say till I index, till index, if we have left amount of elements left, left amount, left amount means left peaks to be done, right? Left peaks to be done, to be done, then till this point we have used a cost rupees, right? And that will be stored in our dp, right? So I hope this is clear to you, what does this dp line mean, right? And how we change that dp, whatever the changing parameters are, index is changing, left is changing, so these two are the changing parameters. All right. So at the end, we are just returning min of pick comma not pick. And at the very end of this main function, we will simply return minimum of answer 1 comma answer 2. All right. So let's quickly look at the time complexity and space complexity of this problem, right? So the time complexity of this problem, if you look, the solve function had two changing parameters, right? Int, index and left, right? Index can go till 5000, right? Let's look at, if you look at this, uh, wait a minute. Really sorry for this. All right. Yeah. So index can go till 5000 and k till go till n, right? So 5000 comma 5000. And if you think closely, it can never be n by 2, greater than n by 2. So at max, it will go till 2500, right? So time complexity becomes 5000, means 5 into 10 to the power 3, and 2.5, or rather 2.5 into 10 to the power 3, which is ultimately 5 into 2.5, which is 12.5 into 10 to the power 6, right, which can be written as 1.25 into 10 to the power 7, right? So this is the time complexity. And similarly, index and left are the same thing which will be used in our space. So space complexity is also 1.25 into 10 to the power 7, right? So I hope the problem statement was clear to you. The code was also understandable to you. I will drop down the code in the comments. Please do subscribe if you have understood, because it's free, and if it will like boost my confidence a lot. Thanks for watching. If you have doubts, please do drop in the comments, and please do subscribe. Thanks for watching.